6 kites and trapezoids. So first we're going to start talking about a trapezoid. There are two different types of trapezoids. A regular trapezoid is just a quadrilateral with exactly one pair of parallel sides. The bases are parallel sides, as you can see up in this picture right here. We have two bases and they are parallel to each other. The legs are our non-parallel sides. And then we have this mid-segment or median. It's a segment that connects the points of the legs of a trapezoid. It's parallel to the bases, and the length is the average of our bases. So basically what happens here is the leg, if you look up in the picture, the leg, which is our mid-segment, is 1/2 the two bases added together. So to find the mid-segment or the leg, it's 1/2 of both of our bases. Now, a trapezoid could look very different. It can have very many forms, but this would be an example of a trapezoid because you have two parallel sides, but then these sides right here are not congruent. And then we also have an isosceles trapezoid, a trapezoid with congruent legs. So up in this picture, you can see they're telling us that these two legs are congruent, which means it is an isosceles trapezoid. And the properties, our base angles are congruent and our diagonals are congruent. So in example 1, we have to find the measure of angle C. This one, if you look, we have two parallel sides, and then our transversal. So these are the consecutive interior angles. So they are going to be supplementary. So if I take 180 and subtract 125, I will receive 55, which means the measure of angle C then is 55 degrees. To find the missing angles here, so we just found that our base angles are congruent here, because we're working with an isosceles trapezoid. Isosceles trapezoid. And then our consecutive interior angles are supplementary. So base angle here, this is 40 degrees. And then 180 minus 40 would give me 140. So this is 140, and this side is 140 as well. So for example 3 for trapezoid HJKL, M and N are the midpoints of a leg, so that's this segment right here. If HJ is 32 and LK is 60, find MN. So this is what I was saying above. The leg is 1/2 the base plus the base. So our two bases are 32 plus 60. So that means that MN is 1/2 the length of HJ plus LK. So those are our two bases. So MN is 1/2 of 32 plus 60, or 46 there. All right, so then if HJ is 18 and MN is 28, find LK. So again, if I write this out, MN is 1/2 of our two bases. We know MN is 28, and we know HJ is 18. Now we can go ahead and solve. So I'm going to solve by distributing my 1/2 into my parentheses. So 28 is equal to 9 plus 1/2 LK. Subtract 9, I'm going to receive 19. And then you can either divide by 1/2 here, and if you do, make sure 1/2 is in parentheses, or you can multiply this whole thing by 2, because 2 times 1/2 is 1. So then 19 times 2 is 38. So LK would equal 38. And then again, if MN is 2x plus 1, so 2x plus 1, and HJ is x plus 1, and LK is 4x minus 4, find the length of the smallest base. So our mid-segment MN, I don't want to add a footer. Okay, so our mid-segment, M, okay. MN is 1/2 our two bases. So HJ plus LK. So MN is labeled as 2x plus 1, 1/2 times. HJ is x plus 1. LK is 4x minus 4. One way that we could also do this instead is multiplying from the very beginning by 2 to get rid of this 1/2. So if I multiply everything by 2, so the whole thing by 2, it will get rid of this 1/2 right here. So then the only thing I need to multiply by 2 by is this will become 4x plus 4 equals, combine like terms, 5x minus 3. And then solve. So subtract 4x, subtract 4x. 4 is equal to x minus 3. Oh, this is supposed to be a 2. 2 times 1 is 2. So 2, so add 3, and x is 5. Then it says find the length of the smallest base. My smallest base here is HJ, so finding HJ is x plus 1, but now we know is 5 plus 1, or 6. All right, in D, if HJKL is an isosceles trapezoid and measure of angle K right here is 50 degrees, find all other angles. So we know here that our angles, so like K and N, are supplementary. So finding all of my other angles, 180 minus 50 will give me 130. So this angle right here is 130. My base angles are congruent, which makes this 130. Then we have a linear pair. So that would be 50, then 130, 50, and 130 there. Okay, our next one is dealing with kites. So on kites, it's a quadrilateral with exactly two pairs of consecutive and congruent sides. So if you look here, we have two congruent sides. This side's congruent to this side, this side's congruent to this side. The properties are completely different than anything we've dealt with. So the properties, opposite sides are congruent or are not congruent or parallel. So opposite sides are not congruent and they're not parallel. The diagonals are perpendicular, so they still do intersect here at this 90-degree angle. Exactly one pair of opposite angles is congruent. So in here, we're going to have that this angle is congruent to this angle here. And then a diagonal bisects the non-congruent angles. So MRN, so this angle and this angle are congruent. And then we have these three angles, or these two angles congruent to each other as well. And then one diagonal bisects the other diagonal. So this long diagonal bisects this smaller diagonal, making these these two segments congruent to each other. So example 1, if WXYZ is a kite, find the measure of angle Z. So we can tell that these two angles are not congruent to each other. Since there are two pairs or one pair of congruent angles, that would make angle X and angle Z congruent to each other. So angle X is congruent to angle Z. So we're working with a quadrilateral, so the total of all of the angles in a quadrilateral add to be 360. So 316, if we subtract out the angles we know, minus 60, minus 80, that would give us 220 degrees left over. And then again, we know that these two angles are congruent, so I'm going to take 220 and divide them by 2 to get 110. That means that the measure of angle Z is 110 degrees. Over here in example 2, it says find the kite's exact perimeter. So again, we know our diagonals intersect at a 90-degree angle, and we have some Pythagorean theorem going on here. So this, we would be using the Pythagorean theorem. Which is a squared plus b squared equals c squared. Once again, c has to be your hypotenuse. So here, my hypotenuse, this side. So I'm going to have 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. Add them together, I'm going to get 169. And C is 13 here. So this side, the length is 13. This side is 13 as well. Now to find the other side, again, the hypotenuse C is directly across from our 90-degree angle, so 4 and 5 are A and B. So I'm going to have 4 squared plus 5 squared equals C squared. So 16 plus 25. And if I add them together, it's going to give me 41. And then take the square root of both sides. C is the square root of 41. So then here, this side, square root of 41, square root of 41. To find the perimeter, I'm going to add them all together. So 13 plus 13 plus the square root of 41 plus the square root of 41. It ends up being 13 plus 13 is 26. And if I have 2 square roots of 41, it's 2 square roots of 41. That's going to be the exact perimeter there. All right, example 3, if GHJK is a kite, find each measure. Find the measure of J, R, K. So here, that measure, the diagonals are perpendicular. So this is going to equal 90 degrees because our diagonals intersect at that 90-degree angle. If RJ is 3 and R to K is 10, find JK right here. So again, we know this is a 90-degree angle. We can go ahead and use the Pythagorean theorem. So 3 squared plus 10 squared is going to equal C squared. 9 plus 100 is equal to C squared. Add them together is 109 equals C squared. Take the square root of both sides, so C is equal to the square root of 109, which means JK is equal to the square root of 109. If the measure of GHJ, so let me erase this on my picture. If the measure of GHJ, so this whole angle up here, is 90 degrees, and then GKH, so this angle down here, is 110, so this is 110 degrees. Find HGK, so I'm finding this angle right here. So again, these are our two congruent angles. So G and J are our two congruent angles. So let's take 360, because we're working with a quadrilateral, subtract the two angles that we know. That would give us 160. Then I can take the 160 and divide it by 2 to get 80 degrees. That means this angle is 80 degrees and this angle right here is 80 degrees. Okay, so if HJ right here is 7, find HG. So as we know, we're working with a kite. These two segments are congruent. So HG then will be 7 as well. All right, if HG is 7 and G to R is 5, find HR. So right triangle here, C is 7, so Pythagorean theorem. So 5 squared plus, let's say, B squared equals 7 squared. So 25 plus B squared is equal to 49. B squared is equal to 24. B is the square root of 24, because I'll take the square root there. That means HR is the square root of 24. All right, almost done. So here, if HG is 10 and HR is 8, what is JG? So first we're going to find this segment right here, again using the Pythagorean theorem. So 10 squared is going to equal 8 squared plus B squared. 100 equals 64. Hopefully you guys have caught on to the Pythagorean theorem by now. So I'll have 36 is equal to B squared. B equals 6. So coming back up here, I know that this segment right here is 6. And the diagonal HJ is bisecting GJ. So this would also be 6, which means that JG would be 12. Okay. If the measure of angle HGR is 30 degrees, I am going to, so it's pretty bad, but that's okay. G, H, J, K, and then R. So measure of angle HGR, HGR is 30. And the measure of KGR is 70. Find the measure of angle GHGHJ. Okay. So here I know that this is a 90-degree angle, so let's figure out what that is. Looking at a triangle here, so 180 minus 30 minus that 90 would give us 60. So this is 60 right here. That means this angle is 60. So the measure of angle GHJ, 60 plus 60 is 120. And then find GKJ, so same thing down here. 180 minus 90 minus 70 would give me 20. So this angle is 20, this angle is 20. So the measure of angle GKJ, 20 plus 20 is 40. And then this next one is a challenge. I'm not going to go through it.